Today we're going to be looking at the first lesson in Unit 4 on equations and inequalities. This one is called Cafeteria Actions and Reactions. And today's objective is, given an equation in one variable, I can write the steps to isolate the variable in 2 out of 2 problems. So we are talking about solving equations in this unit. And here's some things you might think about during this lesson. How is a story of sequential steps like an equation? And how does the structure of an equation give me clues about how to solve it? So first we're going to start with a review of PEMDAS. You may have seen this before, or this might even be new. PEMDAS is the order of operations we use to simplify expressions. So we start with parentheses. We then do exponents. We then do multiply and divide from left to right. And we then do add and subtract from left to right. And this is the order that helps us get the correct answer. Notice that we may need to run through this several times because these operations may happen inside parentheses, and then we have to do the operations outside of them as well. So let's look at an example of how to do this. So here we have an expression. It says to evaluate for x equals 3. So the first thing I want to do with this one is I'm going to figure out how to substitute. I'm going to recall how we substitute. Now I can draw a blue box around equivalent things. See, x equals 3, so both of the things in that blue box are the same. But here's another blue box, because x is the same thing as x, right? So I can substitute any of these things in the blue box in for any other one, which means I can bring this 3 and put it in place of this x in the blue box right there. So let's look at what that looks like. We'll bring the other things down, 4, 2, then I have a box, plus 3, plus 4, all over 8. So you see everything is the same. We've just taken that x out of the box, and now we're going to put 3 in it instead. And we know that 2x, this is a multiply operation, so there's going to be a multiply here as well. And now we're going to ask, what operation do we do first in this equation, or in this expression rather? Well, we ask, are there parentheses? There are. Here are parentheses, so we're going to do that one first. We're going to do parentheses first. And then we have to look inside the parentheses and say, what do we have in here? Well, we have a multiply and we have an add. So we go through these again. We don't have that, we don't have that. We do have a multiply. So the multiply is what we're going to do very first. So this step right here, that multiply, that's what we're going to perform. So we get 2 times 3 is 6. And everything else just comes down. Okay, now we run through it again. Do we have parentheses? We do. We have parentheses, so that's going to be the first thing. And we only have one operation in there, so we know that's the one we're going to evaluate. So we're going to do parentheses, add again, or parentheses again, and we're going to do the add operation that's left. So 6 plus 3 is 9. There's the operation that we did. Plus 4 all over 8. Now we ask what operations are left. See, we have a multiply right here, we have an add, and then we have a divide. So we're really just down to these ones. But how do we know multiply or divide first? Because this is above and below, right? This isn't left to right. This is a multiply up here and a divide below it. So how do we know which one to do first? Well, one thing to think about is that this fraction actually has an implicit parentheses around the top and the bottom. So there are parentheses down there too. But this one is already simplified. There's no operation down here. So we don't need to do anything about that. But we do need to evaluate all these operations inside these parentheses first. So once again, we have multiply and we have add. So we're going to do the multiply first. Parentheses, multiply. I'm going to do that one. So 4 times 9 is 36. And we bring everything else down. Now we go through it again. Parentheses, we do have parentheses. So we're going to evaluate that one first. Parentheses, and that's the add operation that's left. 36 plus 4 is 40. We bring the 8 down. And we only have one operation left, so that's divide. 40 divided by 5, or 40 divided by 8 rather, is 5. So that is our simplified expression here. 40 divided by 8 simplifies to 5. That is this whole expression simplified when x equals 3. So it has a lot of steps, a lot to keep track of. And notice that we did go through these steps several times. Sometimes that is necessary when you have parentheses. So now we're going to go through a story to illustrate how we get equations sometimes. And because we're going to encounter a big block of text, we're going to use this 3 reads approach again. We're going to read it one time and then summarize in your own words, say what we need to figure out. Read it a second time and write the numbers and what they represent. And then we'll read it a third time and suggest a place to start a solution. So I'm going to read the first one for you out loud. Elvira, the cafeteria manager, has just received a shipment of new trays with the school logo. After unloading 4 cartons of trays in the pizza line, she realizes that students are arriving for lunch and she will have to wait until lunch is over before unloading the remaining cartons. The new trays are very popular, and in just a couple of minutes, 24 students have passed through the pizza line and are showing off the school logo on the trays. Elvira decides to divide the remaining trays in the pizza line into 3 equal groups so she can also place them in the salad line and the sandwich line, hoping to attract students to the other lines. After doing so, she realizes that each of the 3 serving lines has only 12 of the new trays. That's not many trays for each line. I wonder how many trays were in each of the cartons I unloaded. So what do we need to answer here? What generally happened and what are we looking for? See if you can answer that. Well, it looks like we got some new trays and they got distributed in some ways. And at the end, it tells us what we need to figure out in the question here. How many trays were in each of the cartons? Okay, so that's a good summary. What we need to figure out. Let's go on to our second read. I'm going to let you read this one silently. You can pause the video and read through it, noting the numbers as you go through it. What are the numbers and what do they represent? And then come back to the video when you're done reading. So I like to use a highlighter when I'm looking for numbers and operations. So I notice here I have 4 cartons of trays. So there's a number. And I have 24 students that have passed through the pizza line. So they took trays. So we're concerned about tray movement here. So 24 trays have left the line now. And then up here I notice she divides the trays into 3 equal groups to put in different lines. So there's a number. And down here as well I see a number. 3 serving lines, each has 12 new trays. So those look like all the relevant numbers that we'll need to consider to solve this, to answer this question. On to read number 3. This is when we're going to decide how might we start solving this problem. So go ahead and pause the video, read it one more time, come back, and see if you have an idea of where we might start to solve this. So what do you think we might do to solve this? Let's see. Well, we have We know at the end here we have 3 serving lines and 12 trays each. So maybe that makes us think this might be 3 times 12. 3 lines with 12 trays each. And we might be able to figure out how many trays we have total there. And if we know that number, then maybe we can figure out how many we had before 24 students took them. And even previous to that, Elvira unloaded 4 cartons. So we might take the result there and see what, if it were divided by 4, what would give that number. So we're starting at the back and moving backward through the problem to try to solve it. So we might try to move backwards and do backwards operations to figure out the answer to this. So let's actually go through these steps. This is a very explicit way of showing what each step was in our story. So we start with an unknown number of trays in each carton. Most of these stories in algebra are going to start with an unknown like this. And I've given it a variable. I've called it n for number. And then we need to reproduce the steps and do some symbolic math with it. So basically we're just going to write some words and figure out what operation it corresponds to. So let's figure out the 3 steps. Let's see. She unloaded 4 cartons. The second step was 24 students took trays. And our third step was she divided the remaining trays into 3 groups. So all we did there was we just summarized the story as a series of steps. We have an unknown. She unloaded 4 cartons of trays. Then 24 students took the trays. Then she divided the remaining trays into 3 equal groups. And at the end there were 12 trays left in each line. So now let's figure out what operation might go with each of these. Well, if she has 4 cartons and there are n trays in each carton, that means we're going to have n plus n plus n plus n trays, right? Because that's 1, 2, 3, 4 cartons. But we have a more simplified way of writing this, which is multiply by 4, right? This is just 4 times n, which we write as 4n. Now, if 24 students took trays, sometimes the words that they use give us an indication of what operation we're going to be looking at. So if 24 students took trays, what do you expect that operation might be? Well, took away, we might be subtracting there. And then the number we have is 24. So we're subtracting 24 from the trays that are left. And we will just append that operation to our expression over here. We've now subtracted 24. Okay, once again, these words might give us a clue of what we're going to do with this operation in step 3. Divided the trays into 3 equal groups. Divided. What operation do you suppose that is? It's divide. Imagine that. We're going to divide by 3. So now we take this whole expression we had before, and we're going to divide it by 3. And the last step tells us what number it equals. So all we do is we just take this full expression, 4n minus 24 over 3, and we set it equal to 12. Now this looks like one of those algebra equations we run into all the time that don't have any context at all, right? We just have a variable and a bunch of numbers and we have to do some manipulations. But this actually is a way to represent that story we talked about. All of these steps are consolidated into this equation right here. And if we solve this equation, we should be able to answer this question: what is the unknown number? So this equation represents a real life scenario. So now we're looking at solving the equation, and we are going to work backwards. That was the method we kind of suggested previously when we were reading the problem, right? We're going to work backwards. And we're going to sort of untangle the operations we did before. And we do that using something called inverse operations. Maybe you've heard of these before, maybe they're new. But an inverse operation is an operation that undoes something else. So they come in pairs. So like plus and minus are inverse operations of each other. If you add something and then subtract it, they go away. So 5 plus 2 equals 7, and 7 minus 2 equals 5. So you can see if we subtract 2 from both sides, we get 7 minus 2, which is that. Multiply and divide are also inverse operations. Squared and square root are another example of an inverse operation pair. So we're going to look at our story problem and figure out what are the inverse operations of our steps. So I've reordered the columns here. I took that last column we did our expression and I put it over here. But it's exactly the same, it's just the same expression down to this equation. And here are the steps we did. We multiplied by 4, we subtracted 24, we divided by 3. Now when we're solving, we're going to go this way. We're going to go the opposite direction. So we will start with our equation, and we are going to go to this step first, but we're going to do the inverse operation. So what's the inverse operation of division? Well, that's multiplication, and we take the same number, multiply by 3. The inverse operation of subtract is add, same number. And the inverse operation of multiply is divide, same number. So now these steps tell us how to solve. Multiply by 3, add 24, divide by 4. We're going to do that on both sides of the equation, and that should give us our answer. So let's give it a try. Let's see if it works. So I've reordered these now so we can just read them top to bottom. We had multiply by 3, add 24, divide by 4. So let's do it. I'll draw my line here. My first step is going to be to multiply by 3. Multiply by 3, multiply by 3. Remember, we have to do on both sides. These 3's cancel, and I get 4n minus 24. On this side, I evaluate. 12 times 3 is 36. Okay, our next step is to add 24. So I'll add 24 to both sides. These 24's cancel. I get 4n equals 36 plus 24 is 60. And my last step says to divide by 4. So I'm going to divide both sides of the equation by 4. These 4's will cancel. And I get n equals 15. So let's remind ourselves now, what did that n represent? There was a story attached to this, right? N was something we were looking for. What were we trying to find? N was the number of trays in each carton. So there are 15 trays in each carton. Great, we were able to solve it. So now a question. Does the order of the steps matter? What do you think? If we change the order on these steps, would it change the outcome? Would it change the number? Well, let's take a look. We just took step 3 and 2 and swapped them now. We're going to do them in a different order. And let's start with our 15 trays per carton and see what happens. Okay, first we unload 4 cartons. We're going to multiply by 4. So 15 times 4 is 60. Now we're going to divide the trays into 3 lines. So divide that by 3. 60 divided by 3 is 20. And now students took 24 trays. This would be in each line because these are now divided into lines. So we get 20 minus 24 equals, wait, this is -4? What does that even mean in terms of trays? How did we get -4? So we lost trays somewhere? Some trays got broken? The school now owes someone trays? Yeah, this step doesn't even seem to make sense anymore. And -4 certainly doesn't equal 12. So that tells us, yes, the steps absolutely make a difference, the order of the steps. In fact, that is exactly why we have PEMDAS. The order of the story reflects how we evaluate PEMDAS. And we put parentheses in to make sure that all the story steps get evaluated in the correct order. So let's look at an example like something you might see on your assignment. This one says, find the first and last operations performed on the variable, then find the first and last steps for solving. So what we mean by first and last operations, we mean if we're just simplifying this over here, like if there was a number in for x, if we substituted in, what operation would we perform on x first? And what operation would we perform last? And like we were looking at that table before, the last operation becomes the inverse of the first step for solving. Since we're doing it backwards, the first operation is the last step for solving, or the inverse of it at least. So let's look just at the expression on the left side here. 3x, 3 times the quantity x plus 5 all over 6. If we plug in a number, we just pick a random number for x, and we plug it in, let's say 3. We don't actually know that's the right answer. We're just going to guess it so we can evaluate PEMDAS and see what order we go in. So what order do we go in now? PEMDAS. Do we see parentheses? Well, we sure do. We're going to do parentheses first. So 3, evaluate what's in the parentheses, 6. And remember, we did also say that on the top of a fraction we have parentheses. We need to evaluate that first, because there are no parentheses on the bottom now. So 3 times 8 comes next, which will be 24. And then we can perform that division. 24 divided by 6 is 4. So notice this step was, we added 5 here. And then to our answer, we multiplied by 3. And then we divided by 6. Those were our steps. So our first step was to add 5, our first operation, and our last operation was to divide by 6. Now we know our first operation is going to be the inverse of our last solving step. So what's the inverse operation of add? That'll be subtract. We keep the same number, subtract 5. That's going to be our last step for solving. Our last operation, what's the inverse operation of divide? That will be multiply, and we keep the same number. So these are our first operations. This is our first and last operations. These are our first and last steps for solving. So let's see if we can actually solve it. This problem, notice, doesn't say to solve it, just asks for the steps. But let's see if we can solve it now. Notice our answer here is not 4 because we assumed this 3 before. Right? We would get 4 equals 7, which is not a true statement. In order to find the actual value of x, we have to solve this. So our first step is the opposite of this one, right? Our first step is multiply by 6. I'm going to draw my line here. Multiply by 6, multiply by 6. These 6's cancel. I'll bring the rest of this down. 7 times 6 is 42. Now our next step is the inverse operation of multiply by 3. So that's going to be divide by 3. Divide by 3. Those 3's cancel. We get x plus 5 equals, this is 14. 42 divided by 3 is 14. And our last step is the inverse operation of add 5. So what's that? It's going to be subtract. Oops, subtract 5, not 6. Subtract 5, subtract 5. These 5's will cancel. Inverse operations. We get x equals 14 minus 5 is 9. That is our answer. X equals 9 is our answer here. Notice if we plug this back in, we should get 7. So 9 plus 5, this whole thing is going to be 14. 14 times 3, this top bit is going to be 42. And indeed, 42 divided by 6 is 7. So we got the right answer. So that brings us to today's objective. Given an equation in one variable, I can write the steps to isolate the variable in 2 out of 2 problems. We looked at the justification behind solving steps, working backwards and using inverse operations.